Hello everyone. So in today's lecture again we will continue the same chapter 10. So in previous lecture already we have discussed what is quality control of concrete, then need for inspection and quality control, then what is quality, principles of inspection, different stages of inspection and quality control, then different factors causing variations in the quality of concretes already discussed. So in today's lecture I am going to discuss about what is advantages of quality control in concrete. So let us discuss some advantages like quality control means a rational use of the available resources after testing their characteristics and a reduction in the material cost. And in the absence of quality control at the site, the designer is tempted to over-design so as to minimize the risks. This adds to the overall cost. And also quality control reduces the maintenance cost. And in the absence of quality control, there is no guarantee that overspending in one area will compensate for the weakness in another. Again, quality control provides a guarantee of desirable quality at every stage of works. So these are some advantages of quality control. Let's discuss some disadvantages. So a major problem is that individuals are not necessarily encouraged to take responsibility for the quality of their own work. This is a major disadvantage. Again, a quality control approach can be highly effective at preventing defective products from reaching the customer. However, if defect levels are very high, the company's profitability will suffer unless steps are taken to tackle the root causes of the failure. So these are some major disadvantages of quality control. Let's see some requirements of good concrete mix. What are the requirements? Like the concrete should be mixed thoroughly to form a homogeneous mix. Concrete should be compacted properly to prevent it from being porous. Sufficient curing of concrete is required for developing full strength or to find full strength of concrete. The water cement ratio should be appropriate considering the strength and workability criteria. So these are some requirements of good concrete mix or to find a good concrete mix. Next is the important overall requirements are related to measuring, mixing, transporting, placing, curing, inspection. That means the total process of preparing concrete mix. So overall requirements are all materials should comply with specifications. The methods of storing, handling and measuring all ingredients should be such that the selected mixture can be accurately obtained at all the times. And the concrete should be adequately mixed and it should be transported and placed by methods that will avoid segregation and loss of ingredients. So these are some important requirements. Another thing, this important short note type question, this is alkali-aggregate reaction. So the chemical reaction in either mortar or concrete between alkalis from Portland cement and other sources and certain constituents of some aggregates are known as alkali-aggregate reaction. And it occurs when aggregates in concrete react with the alkali hydroxides in concrete producing a hygroscopic gel which in the presence of moisture absorbs water and causes expansion and cracking over a period of many years. This alkali aggregate reaction has two forms. We can say one is alkali silica reaction ASR and another one is alkali carbonate reaction. This is ACR. So let us discuss one by one. First is alkali-silica reaction. That means it is of more concern because aggregates containing reactive silica materials are more common, and in ASR aggregates containing certain forms of silica will react with alkali hydroxide in concrete to form a gel that swells as it absorbs water from the surrounding cement paste in the environment. And also this figure shows the alkali silica reaction of concrete surface. And the next is alkali carbonate reaction, ACR. It is observed with certain dolomite rocks like this as shown in the figure. So this reaction and subsequent crystallization of brucite may cause considerable expansion. The deterioration caused by alkali carbonate reactions is similar to that caused by ASR. However, SCR, that means alkali carbonate reaction, is relatively rare because aggregates susceptible to this phenomenon are less common and are usually unsuitable for use in concrete for other reasons. So these three things are most important, as we have to take care of it for or to find a durable and strengthened concrete. So with this chapter is completed. Thank you.